Okay, welcome back after the reading week. I hope everyone enjoyed their break, well-deserved break. And now we are almost, well, not yet to the final stretch. We are entering the second half of this term. So, what's today? July 3rd, 2025, ELEC 1013, Network Cabling Class, Fanshawe College, London, Ontario. There we go. Here's the preamble speech. All right. So today we're going to take care of a couple of loose ends just before I release the test at the end of this week, and the test is going to be as usual up to now. All right. Cool. So what are those loose ends that we need to tie before the testing here? It's this part of the coaxial cable right here. We were not able to finish that. All right, so as we remember, the coaxial cable is serving as something that's called a radio guide to guide radio waves inside the cable, which, if you can say that, but that's why the designation of the coaxial cables, designations of the coaxial cables start with RG, which stands for radio guide. Now, what is that associated with? Well, I'm going to introduce you to multiplexing and other things as we go along. So let's take a look at something that's called a broadband connection. Quite often, you will hear that, yeah, our internet is broadband. And you hear that a lot. What does that actually mean? Let's say broadband internet service is the most used form of internet access because of its high speed, high access speed. It is offered in 4 different forms: the internet, DSL, which stands for digital subscribers line, and DSL is the connection that you get through a telephone line, which basically is sometimes you will get a telephone line. Well, you have that. Most of the households still do have active or working telephone connection, telephone line connection, CO lines, central office lines, and the internet signal is superimposed on that telephone line. We went over that. Fiber optics, cable, and satellite. All right. As opposed to the broadband connection, we used to have. Now, by the way, broadband is not just reserved for the internet delivery. Broadband covers all kinds of different signal deliveries. Now, as opposed to the broadband delivery of the internet, the old dial-up connection is the only non-broadband internet service. Now, you might want to, some people might want to say that used to be available, but believe it or not, it still is, and I'll show you how. And even though it is cheaper, most internet users, well, are moving towards the faster broadband internet connection. I think that it's supposed to be in the past tense by now, because that's 2025. All right. Ethernet. The signal type is digital. So broadband versus well, time division multiplexing. So the Ethernet is a digital signal, bit delivery, time division multiplexing, baseband. As opposed to broadband, there is baseband. Now, from the outside, so when we are talking about the internet connection, the turning point is the modem. Remember, modem stands for combination of two words, modulation and demodulation. And combining those two words, you get something that's called a modem. Modulate, demodulate. The internet signal that is between modem and the outside world, so it is delivered to the modem from outside in an analog form. And the best delivery for that is something that's called a frequency division multiplexing. Let me just get my my board ready. So as we speak, my board is going to start initializing. Now, let's talk about broadband versus baseband. It will all become clear after this. Broadband connections are divided into channels. Some of the simple example of the broadband type of signal delivery would be the air that carries all the radio stations. You're driving in your car and you tune in to some sort of a radio station. Your radio tuner chooses from all the frequencies that are quote unquote flying in the air, flying in the air, it tunes to one of them. And that's the only thing that it's listening to, your radio tuner. If you want to listen to a particular radio station. Same thing can be accomplished in cables. You can have many different frequencies and a tuner is involved in order to tune in to the particular frequency that the receiver wants to listen to. Now, I'm just getting my board set up here. That should be good. Oh, that's way too thick. I'm just there we go. This should be nice. It's on my other monitor. Sorry. All right. So let's just take a little bit of summary of that. Broadband. Connections are divided into channels. Each channel occupies space within all the spectrum that the medium, in our case, cable, can handle. All channels are injected into the medium, in our case, the cable, all at the same time. The cable TV used to be delivered in the broadband in a little bit different way. That all the channels were present at the same time at the cable TV that was delivered through your cable. So when you were flipping through the channels with the remote control, the channels would appear right away. It would be just almost no delay. Flip, flip, flip. Those channels would be there. Now, if you want to switch the channel on TV, it takes about, well, half a second to sometimes to 1 second before the channel locks on to the digital transmission that is being offered. All right. Communication between devices is established through tuning to a specific frequency. And in this case, frequency division multiplexing is being used. Now, let me get the board here and go over the mysterious term that says multiplexing. Multiplexing. Bit of a primitive way of showing that, but hey, why not? Simplest explanations are the best. Let's imagine a bunch of channels or points here, and whatever the amount of that is. Okay. Now, what I'm going to do is I'm going to copy that. I'm going to paste it. All right. So here's the transmission end, here's the receiving end, or vice versa. Now, let's say here is a ground reference for both. So that's one side of the cable. And the other side of the cable is connected to a dial. Let's say the dial makes a connection with this point, and same way the dial is connected to that point. And let's say here is the other wire. Right? And we can connect things like that. Maybe not. Over here, these points are connected to specific telephone sets. Each of them has a connection to a specific telephone set. On the same thing would be on the other side. And I'm just going to go through that. Yeah. All right. Now, don't like it. Let's just go here and go outside of the device. All right. Now, let's say here's a telephone set. Here's a telephone set. And each of them those points are connected to a telephone set. Notice you only have two wires. But 1, 2, 3, 4, 5, 6, 7, in this case, 8, I think. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, on each side. Well, according to what we're talking about, you can only have one conversation per pair. Well, humans always try to improve things and inventing ways for us to be the most efficient that we can. So these two wires, there's a pair of wires, there's a conduit somewhere going from one point to another point, let's say in the same building. If the dial switches to this point, then this telephone set and this telephone set are having a conversation. Now, if the dial switches to this point right here, instead of having these two connections, let's whoa. Let's erase that and let's make a switch. Now we're connecting these 2 points. Now, this telephone set and this telephone set are connected. All right. And if we keep switching those dials, and if we synchronize these 2 dials so they're both switching at the same time, you're going to be switching the transmission over this wire. It will be carrying different conversations at different time. Well, if there's only one conversation happening, there's only one connection, then you can just switch it to that and leave it that way. And these 2 people are going to have a conversation. When they hang up, you can disconnect. But what if there are 2 people that want to have conversation? Let's say at the same time. What could you do? You could just switch between those points and give them, let's say, 30 seconds each to talk. And another 30 seconds, they're going to be a silence and wait for your turn to talk. Well, that would be time division multiplexing. You are sharing one pair and you are time division multiplexing, allowing each party or 2 parties or each conversation to have their time on this wire. It's, well, it's some kind of a solution, but not as efficient as we would like it to be. Well, what if we have those 2 dials synchronized, and if we have them spin extremely fast? Let's say there will be like milliseconds or maybe even less time of the switching. Now, if we spin those 2 fast enough, you could have all these conversations happening all at the same time. And our human ears that are connected to our human brains, where there's a red thing connected to the blue thing and all that stuff, Dr. Nick, we would not be able to even tell that the switching is happening. But things have to be done very fast. And those 2 dials will have to be precisely synchronized. So this is time division multiplexing using only one pair to establish a conversation between more than one party all at the same time. So that's a multiplexing that is involved time division, time sharing, or time division multiplexing. Broadband is using frequency division multiplexing. Here is a multiplexer, and here's a demultiplexer. The multiplexer is going to have, let's say, here is the coaxial cable. Now we're talking about the broadband. This was time-based division. Or baseband. This is broadband. I'm switching between those 2 to show you the difference. Let's say we have different channels, TV channels, radio channels, all fed into something that's called a multiplexer. The multiplexer is going to combine all the frequencies. Let's say this radio frequency, this radio channel is on certain type of frequency. Here's another radio channel that works on another type of carrier frequency. And here is the third radio station that transmits on yet another carrier frequency. The job of the multiplexer is to kind of mix those together and send them down the medium, which could be either air or a cable. And all of those frequency, all those channels, this is just 3, but you could have 100 channels, depending on the capability of the cable of carrying certain frequencies, or how many frequencies we can carry on one cable. Which we call bandwidth. All right. Now, multiplexer's job is to combine all those frequencies onto one medium and shoot them down so it goes. Now, the job of the demultiplexer, and these are just abbreviations of multiplexer, demultiplexer, is to split them again into individual channels at the other end. So you could listen to one channel, or you can listen to another channel, or you can do it one at a time, or some of the demultiplexers can do it. So you could connect 3 different devices to the same demultiplexer, and you can listen to them or watch them all at the same time, depending on what kind of demultiplexer. So this one combines things and shoots them down the channels, and this one decombines it and splits them, fanning them out again into the individual channels. So this would be a frequency division multiplexing, which is associated with broadband. Now, let's go to the time division of multiplexing, or baseband, with this little contraption that I drew. This would be time division multiplexing or baseband type of transmission. Here we have a multiplexer, and we also have a demultiplexer, but time division is being employed. The multiplexer says, hold on, I'm going to send one channel at a time, but I'm just going to switch very fast. So first is going to transmit channel A, then is going to transmit channel B, C, D, and again, A, B, C, D. So it's just basically switching between those channels very fast and sending them down the line one at a time. And the demultiplexer is supposed to be synchronized with the multiplexer. Now, it could be synchronized at the same time, or it could be operating at the same reading frequency, which also we call baud rate. So if this one is switching at a certain speed, and because we do have something that's called a propagation delay, which is basically a delay that takes for the signal to get from one end of the cable to the other if it's a long transmission, then the real life synchronization will not be possible. So usually you would have that multiplexer send like a flag signal, say, okay, start listening. I'm going to transmit with speed so-and-so, so switch those with this exact speed, and the transmission starts now. Right? So that one is going to start reading, and then within that type of synchronization, yes, you can also distinguish or discriminate between those channels based on the time division multiplexing versus broadband transmission, which involves frequency division multiplexing. So let's just compare these two. With the broadband, connections are divided into channels. Each channel occupies a space within all the spectrum or bandwidth of, let's say, the cable. All channels are injected into the medium at the same time. Communication between devices is established through a tuning to a specific frequency. And we're talking about frequency division multiplexing, FDM. Now, baseband right here, there's no channel division. Each communication link occupies all the bandwidth that the medium can handle. So this doesn't have to have wide bandwidth as this cable. Right? So each communication link occupies bandwidth that that the medium can handle. So we are maximizing the usage of that. Each communication link waits its turn to talk in a time sharing manner. Time sharing happens here. No tuning is involved because the signals are not assigned to channels. Sometimes some sort of tuning could be involved, but just to make a connection between those two, but there's not going to be any channel switching. So in this case, we are talking about time division multiplexing, which is associated with the baseband transmission. Now, let me talk to you about the good old dial-up connection. How is it that it was happening? And why is Bach talking to you about that in 2025? Well, there was a reason. Excuse me. All right. How was the dial-up connection made? Here was the old PC. Let's see the cathode ray tube monitor. And here's a modem. And the modem was connected to a telephone line. It would pick up the telephone line just like if you're picking up the phone. There was an old, well, sort of a high-tech movie released sometime in 80s. I don't remember. I think it's called War Games. That's when some high school kid was able to break into some government institutions and do some things. It was an early hacker, and because the movie was done in 80s, then that type of modem, even older, was shown on TV, shown in that movie. So yeah, it's a fun movie, kind of retro type of movie to watch. Except it was it was shown on that movie that when the computer couldn't handle the calculations, it was so overloaded that the monitor blew up. Yeah, okay, but that type of a modem was used. Dial-up modem. It would pick up the phone line. It would dial a specific phone number of something that quite often were called bulletin boards. And the bulletin board was a server connected to a bunch of telephone lines, and you could have so many simultaneous connections depending on the ability of the server. But it would be connected somewhere that you could dial up a number, that device, whatever on the other side. So over here is a modem. It goes through the telephone lines. Here's a local exchange, which is a building, just like PBX, private branch exchange, but it was not private branch exchange. It was the local exchange, which services certain amount of telephone lines within the region in the city or a neighborhood. And those were connected to each other, and all that switching would happen. And at the end result, you would get a connection through the telephone lines with another modem that goes to another server. What did I say here? Dial-up internet access is a form of internet access that uses the, notice I'm not using past tense, even in 2025. Dial-up internet access is a form of internet access that uses the facilities of the public switched telephone network, PTSN, there we go, to establish a connection, which uses telephone lines to dial up a number, and something picks up the phone on the other end and makes a connection. Internet service provider, by dialing telephone number on a conventional telephone lines. That's how the connection is made. Dial-up connections use modems to decode the audio signals into data to send to a router or a computer and to encode and decode from the ladder two devices, the devices that we were talking about, which would be the modem or PCs. It's a very slow connection. How slow? Well, if you wanted to get a picture that was 1 megabyte, you would request the download of the picture, and usually it would be something ridiculous like a big, colorful parrot. Amazing. And that you would just go for coffee and come back, and the picture will be almost on the monitor. Dial-up connection. Dial-up internet connection is not quite out of the market yet, although it is not popular as it was in 90s. Dial-up modems are still used in a specific situation such as backup connection, mostly in the retail business, but not only. Example, in retail, if the computer network fails, no sales can be made. It used to be just those mechanical crank cash registers. If you want to buy a chewing gum, somebody would press a few buttons, crank the crank, and the numbers would show up, and transaction was made. Now everything is connected to VPN and computer systems and through network, so you can't even buy a chewing gum in the variety store if the network fails. So the system can disconnect. So how this is, backup system. The system can disconnect from the main network and automatically engage with the dial-up modem, which is connected straight through a POTS line. The modem will dial the phone number of the designated receiver, connect with it, and internet connection will be slow, but it can have enough bandwidth to service one cash register. The sales will be still moving, and the store will still be in business. Let's say a store has 6 cash registers, because that's how many cash registers they need to have a normal operation. Network fails, 5 cash registers go offline, they're being shut down, closed, and one that is connected to the dial-up modem will work. The sales will be slower, but still you can get by until the network is fixed or repaired. As a service technician, you might encounter service calls during which you will service faulty equipment while the dial-up backup is engaged, or you might simply perform a dial-up test because some of those services, stores or retail agencies, facilities, excuse me, they'll have that installed, but maybe once a month or so, that system will have to be tested just to make sure it works. So you would go to that store at some hours that are not busy, and the store is not busy, and you would just go and pull the plug on the network and see if the modem kicks in and if all the connection is done. Now, when you see sometimes in some retail point of sale countertops or counters, when you pay with debit or Visa or MasterCard or whatever credit card, when the transaction goes blip, done, that means it's connected. The transaction is made through a computer network. But sometimes when you do the transaction and you have to wait maybe 10 seconds, 15 seconds before you goes, oh, okay, then, it could be that the network is busy, or it could be just because that money machine is connected through a dial-up. It dials a phone number, makes a connection with the server, does the transaction, and hangs up the phone line. So here would be a typical small business type of rack. Here are the field wiring. Here's the field, not that small business with this one here. Here's the field wiring connected to patch panels. There's one-to-one connection through the field wiring, through the desktop, someone's PCs or cash register or whatever. Cash register is a PC with a money drawer set up a certain way. And from here, you got patch cords or patch cables connected to something that's called a switch. We briefly talked about it already. It's a traffic controller for the computer network, for the signals. And then there could be a modem, gateway, programmed certain way with the permissions and restrictions and addresses and all that stuff, characteristic to that specific business. And look here, there is a modem. That if everything fails, it is set up to just work maybe with one cash register. Or, if it's a business, it could be any kind of device. So yeah, that is still being used. Now, we still have time. There's another loose end that I want to tie with you here. Remember I said we're going to come back to this? All right, let's go through some of the features. Telephone features. This is from the previous broadband versus baseband was from the coaxial cable lesson, and this one is from the conventional telephone systems, or basically telephone systems. All right, let's see here. Pulse or DTMF. There used to be the rotary dial phones that most of us don't know how to use, but it's kind of quite simple to use. You would just dial a number with the rotary dial, or sometimes you will be programmed with the push button that the number that was sent, the information about the number that was dialed, was sent to the central office with a bunch of pulses, line interruptions, tick, 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 and so on. Okay? It was the first way of dialing when things went automatic. Now, DTMF is a quicker type of dialing, and it comes with certain type of benefits. Dual tone multi-frequency dialing. Well, different numbers are assigned different frequencies, but why is it that we need dual tone? The receiver that is trying to understand the number that you have dialed needs to hear two specific tones for each number. Because if there was just one tone, it would pick up the phone, and maybe there's a TV going on, the radio playing, or whatever, music going on, people talking. By accident, some of the frequencies could be momentarily present at the microphone of the telephone, and the dialing equipment on the receiving end would mistakenly interpret that as a number pressed. So if there were two specific tones for each number, then that problem is eliminated. That's why it's called DTMF. With this one, when you're programming telephone systems, um, there is well, different type of areas to program, and one of the areas in the telephone system is to program the lines, and it's basically called line programming, telephone line programming. And one of the first things that the system is going to ask you whether you want to have the line to be working as a pulse dialing or a DTMF dialing. Right now, you program this thing as DTMF. In some maybe far, far ends of the world, maybe still some of the pulse dialing is implemented, but I doubt it. Excuse me, but that thing's still there as an option. If something goes wrong with the programming because you have a phone system installed for a client and the client calls you and they say, look, we can dial out to get the number, but when we get the options of press 1 to get this, press 2 to get that, uh, it seems like whoever is on the receiving end, it's not reacting. We can't do the selections. It's because maybe there was a lightning hit or a power outage or something that made the phone system switch mistakenly to the pulse dialing. So you just go back to the line programming and make sure that the lines are programmed as DTMF. Because you can dial it and the system will understand the pulse dialing, so it will connect you. But the system, instead of producing tones, which the menu equipment is looking for as your response, it will not understand the pulses. It's listening for the tones, and it will not produce your system will not produce tones, it will just produce pulses. So that's one of the common problems. Ground start and loop start, we talked about that. Remember the telephone lines? What did I just do? Maybe, let's see. All right. The telephone lines would be here's the lines along the rail tracks here. Each line would have telephone conversation, and on the other side there would be a ground reference used. So that would be a ground start type of a connection. There will be one line per conversation, and the ground reference will be provided with the actual ground. So it will be a ground start type of connection. Why this is called start? It's to initiate the call. I don't know how it was, what was the reasoning, but it just established itself and it stayed for a long time. Ground start. Now, right now we have one pair of line of conductors per conversation, per connection. So that's a loop, right? Here is a telephone set connected, and the whole thing is just making a loop. Right? I don't know why those are still present when line programming, those options, but you need to make sure that those lines are set up as loop start. All right, DOD, direct outward dialing, direct inward dialing. There's a feature in the phone systems that when you pick up the handset, it selects a line, an outside line. You don't have to press 9 to get out. No, that phone set can be programmed that if you pick up the handset, it gives you a first available line that is free for you to use. Same as direct inward dialing. Once you pick up the handset, the phone set can be programmed. So as you pick up the handset, it gives you the dial tone, but of the internal system. So you can dial somebody's extension. So you don't have to press. Usually it's called the intercom button, and then you get the same sounding dial tone, but it's within the system. and there's a hotline, which would be DID or DOD, you know, but specific numbers being dialed for you. So pick up the handset, phone selects either internal line or outside line, and it dials a specific number. Very popular for those taxi cab companies that they have their phones installed in large department stores by the exits, by the doors. If you want to have, if you want to call a taxi, you just pick up that phone and it's hot dial programmed to dial. And those phones are being purchased by the taxi companies because they want business. Right? So that's why you can see those phones with no dial buttons, just a handset. You pick up and it is set up as a hotline. 911 line or set. A single line, a POTS line, connected directly to the central office and to a single line telephone, bypassing any KSU or PBX or anything. It just goes straight outside and it's connected to a telephone, maybe on a production line somewhere in some sort of factory. So you could pick up the phone and you can, well, usually you can dial any number from there, but the purpose of that phone is so you could dial 911 if there's a need. And with the 911, there should be one telephone set per one line. You can't, well, you can, it's possible physically to parallel connect or daisy chain connect multiple phones to the line. But the problem is that if there's a telephone set on one part of the, in one spot of the large production hall, and the other phone using the same line is connected far at the other far end, if somebody doesn't hang up properly one of those phones, then the other one is being useless. So for that reason, there should be one CO line per one telephone set that is designated. So if somebody needs, they can dial 911, right? Single line versus proprietary telephone set. Okay, let's see here. Yeah, it's 1050. So just as I say, always, sometimes you need to go to the to another class. So go if you need to, and I'll keep going, and you can catch the rest of it when I post it. Oh, I can see some chat lines here. I remember dial-up; it sucked. Okay, Robert. Yeah, but we know just with certain people, some sort of sentimental value can be associated, right? And Doug says, "Cash is king." I absolutely agree with you, and that's all I have to say about that. Hotels don't seem to think for some reason. Um, okay. To punk rock for hotels, toast on the TV. All right, so it's probably was when I was talking about the multiplexing and cable TV. All right. Regarding the cash comment, yeah, okay, I get it now. Yeah, you need to have credit card or something to even get a room at the hotel. Yeah, I agree. All right. So single line versus proprietary telephone set. Single line telephone set is just POTS telephone. It understands the POTS signal. Simplest telephone line you can get. And that telephone you can right now probably buy for $9 at some sort of a surplus store or department store. Proprietary telephone set, we talked about that a little bit before. It's a telephone set that is supposed to work with a specific telephone box, a system. Toshiba, Panasonic, North Star, Meridian, if someone can find those still. It is not going to work if you plug it into POTS line. Music on hold, MOH. Well, simple idea. If somebody, if somebody calls in and say, "Can I put you on hold?" Yeah, sure. Okay, whatever. Yeah, all right. So put you on hold and we listen to some music. However, that as I was saying to you before, MOH has become a business because somebody had a clever idea of um, contacting companies and say, "Hey, instead of having a radio when you put people on hold, why don't you have this device? What is this device? Oh, this is device that it hangs on your wall, connected to the network, and when we need to, we can log into it and push an audio file that maybe it's 1 minute long, 2 minutes long, 3 minutes long, and it talks about and the audio line contains the advertisement for your company. So when client is being put on hold, they're going to hear, "Did you know that we have special on this and that, the other thing this month," and so on. And it's a paid service because every month there are different specials. Uh, they they have maybe Zoom meetings or telephone calls to say, okay, we need to make sure that we are advertising this, that, and the other thing this month. So can you make a file? Of course, for some amount of money, they will, and maybe there is some monthly fee associated with that. Oh, clever idea, music on hold. Why didn't I think of that? We are a millionaire now. Well, dry contact relay. Not going to PI paging interface. We spent so much time on it before. CO central office line. We already talked about that. Single line. SL stands for single line. POTS line. Rollover. Rollover. Let me get my board. Here. Let's say the telephone, the telephone, the a business has purchased line 1, line 2, line 3, line 4, line 5. Okay, let's say they purchased 5 telephone lines, 5 CO lines. It could be SIP lines too. But let's say 5 CO lines, CO, central office line. And according to that, calculating the number of employees that need to use the telephone at the same time, this should be enough to service that business. Problem is, problem. Here's the challenge. Each of those lines has a specific designated telephone number because that's how those lines, CO lines, are being delivered. Each one has a distinct telephone number. But so what would you do? If you want to advertise your business, you would say, okay, you can all call us on this number, that number, that number, that number. That would be silly. Right? What if you have 100 numbers? You're going to publish 100 numbers to call you on? So what happens is that one of those telephone numbers, let's say line 1, but it could be any of those, can be chosen as the main published number. And that's the only thing that's going to be published. And those 5 lines by the CO, by the central office, by the telephone provider, can be pulled into a group that is called a rollover group. So if somebody is talking, somebody dials that main published number, and somebody is talking on the phone, then this line will be busy. Well, then in the central office, the equipment is going to, without you even knowing, is going to switch you to that line. And line 2 in the reception is going to ring, and so on. If that line is busy, then this will be activated. In that one, and this will be active, and that one is busy, then it will try to look for the line 1 first. Maybe it became free now. So that's the rollover sequence. You order those lines. Let's say you're calling the telephone line provider and say, we need 5 lines to be in a rollover sequence. Sometimes you're going to have more than one rollover sequences. So you're going to order rollover A that consists these lines, rollover B that consists those lines, and so on. And at the company side, at the business side, you would say, okay, pick up, dial 9 to get out. And let's say the 9 number could be associated with the rollover sequence A. Or dial 8 to get out. That number 8 could be associated with some other lines that are in one rollover. Yeah. Now, here's the challenge. Again, one more challenge. When you dial out from the business, your telephone system is also programmed to hunt for first available line that is going to include those lines in that hunt group. And it's going to select line 3, for example, which has different number than the published number. However, on the call display on the receiving end, somebody from outside, the published number is going to appear. So if the lines, whichever line is involved or included in some sort of a rollover sequence by the telephone provider, when you dial out, what's going to be on the display is going to be the published number. Which brings us to a little bit more challenges with, and I'm going to talk about that. Actually, right now. PBX, private branch exchange, we talked about that. It's a telephone box, or it could be a room with telephone equipment if it's a huge one, let's say a hospital or a big office building. Now, here's the ELEC number, automatic number announcement circuit. Well, if you are trying to find out, because you're looking for a specific number to service, if you're the telephone technician going into because something's happened. For example, what could happen? There could be another line 6 that is not part of this rollover. But all those are just terminated on the BICS termination strip. Somebody, by mistake, I've seen those service calls, of being sent to those service calls. And you have to play a little bit of a detective. Problem was that when the clients call us, sometimes they hear the fax machine. And when we call out, sometimes there's just different display being shown. Well, if somebody connects line 6 instead of line 4 and line 4 instead of line 6 and connects that to fax machine, that could create a bunch of mess as far as the call routing. So in order for you to remedy that problem would be to find out in the individual number of all those lines that are connected, and some of them will be labeled and some of the labels will be gone. So it's your job to find out which number each line has, but you can't just clip onto that line with your diagnostic set and dial out your cell phone number, because every time if it's in the rollover sequence, you're going to see the published number on your cell phone. That'll be a problem. That's why there's something that's called an ELEC number. Some well-established for a long time on the market telephone companies will have that service. Like, for example, Bell Canada does have that. If you are looking at the Bell Canada line, pick up the phone, but it has to be Bell Canada POTS line. Right? If it's any third party, it's not going to work. If you dial that number, the area code that you're in, plus dial those numbers, you will hear the number that you're actually connected to, you're calling from, which means If you dial that number from that one, line 4, it's going to tell you this line number, not the published number. That's how you can sort things out and say, oh, we have just switched these two lines, and reconnect things using the cross connect wiring that we're actually doing during this lab this week right now, class of 2025. And that's how you can use that. That's the KSU, same as PBX. We talked about that. POTS, we already talked about that. We talked about the tip and ring. We talked about the ATA, analog telephone adapters, battery present, 48 volts DC, or actually negative 48 volts DC. If you're troubleshooting a faulty telephone line, you're going to be looking for two things. You're looking if the battery is present, and you're going to be looking for the dial tone. Battery present, it means that there is that DC voltage across those tip and ring terminals. And then on top of that, there should be a dial tone. So you could say to the telephone provider, say, hey guys, we have the battery present, but we have no dial tone. So maybe some of your circuitries are, knocked out of, power or something like that. Right? So that's basically the terminology that's involved with that. RJ stands for registered jack. Standardization had to be implemented when different companies, long time ago, the early telephone days, everybody and their brother, or maybe there would be companies that would be the designated companies to service some of the telephone system, and they would invent their own connections, their own connectors and stuff like that. Now, when the telephone systems became the telephony became more popular, then some things have to be done to address the problem that things have to be standardized. So RJ stands for registered jack. RJ11, RJ12, RJ45. Trunk, multiple telephone lines physically bound into one cable. So in at the telephone provider, Bell Telephone, Bell Canada, or Telus, or other companies, AT&T, in the States, and others, usually the big ones who provide CO lines, they say, okay, this is the London East trunk, which is a lot of telephone lines combined within one big cable, and that services the certain neighborhood, for example, right? So trunking is basically combining multiple telephone lines into one cable. All right, so yeah, we went 7 minutes over time. I guess a lot of people stayed here, so that's good. Thank you for staying. And that's about it that you need to have for the upcoming test. And I will release that sometime. What's today? Thursday? Today is Wednesday? Thursday. I'll release that thing sometime towards the end of tomorrow. Okay? As far as tomorrow's theory class, because we had Monday was a holiday, which means I cannot this week deliver some material to certain groups and not deliver it to certain groups. So this is it. This is the theory class that you're getting for this week. So tomorrow, when we have that one in-person class, I will be there. If somebody wants to clarify something, talk about some things that have to do with the class, or maybe do some clarifications on certain whatever things, you can talk about anything, well, within the subject, and I'll be there. If nobody shows up within 15 minutes, then I'll just shut down the session. All right, but there's going to be no new content tomorrow because we couldn't do that on Monday. So that means the Friday is also affected. Cool. All right. That's it for today. Thank you very much for your attention, and I'll see you next time.